Hello everyone. Now we're going to look at what is a unit circle. So a unit circle, by its name you can tell the radius is 1, so it's only 1 unit. So no matter where you draw, so from the center to the circumference, the unit is always 1. So the unit is always 1 from the center to the circumference. Then let's have a look at what's going to be my so let's look at here. So I have a point P, and at this point here we know that it's x, y. So we know our height is this distance. So here we know the height is going to be y, and this distance here from here, this is the distance is going to be x, the value of my x. Then as we can see from here, this creates a right angle triangle. Therefore, we can look at our SOHCAHTOA again. So our SOHCAHTOA So from previously we know that the opposite side is going to be y. The hypotenuse is going to be 1, and the adjacent is going to be x. Therefore, we know that sin theta is going to be equals to opposite, which is y, over hypotenuse, which is 1. Therefore, sin theta equals to y. So we know y is equals to sin theta. Then we look at cos theta. So again, we know that cos theta is equals to the adjacent, which is x, over the hypotenuse, which is 1. So we know that cos theta is just going to equals x. Then we look at tan. So we were taught that tan is the opposite over adjacent. So tan theta is the opposite, which is our y, and over our adjacent, which is x. And we just found out y is the same as sin theta, and x is the same as cos theta. Therefore, another thing we can find out here is that the gradient is the difference in y over the difference in x. So gradient is equals to the difference in y over the difference in x. So the difference in y, as we can see here, is sin theta. And the difference in x is, as we can see from here to here, is cos theta. Then we see that tan theta is going to equals to be our gradient. So this is tan theta. So we also know that gradient is the same as tan theta. So since we know it's our unit circle, we can find out the values for each of them. So cos theta tells you the x values, sin theta tells you the y values, and tan theta is your gradient. Then we can start to fill in your table. So I'm going to do the first one for you. So when theta equals to 0, so another thing really important, when we're measuring the angles, we always measure anti-clockwise. So start from 0. So when it's 0, so our cos theta at this point when theta is 0 is this point here. So cos theta is our x value. Therefore, x is just equals to 1. And the value of our sin theta, which is the height, and that's 0. And the gradient is 0. Because 0 divided by 1 is 0. Let's look at another one. So we want to find out what the x values are going to be. Is it positive, negative, or are they positive, negative, or 0? So let's have a look. So we're now looking at what's going to be the angles. What's going to be the values in this region here when the angle is between 0 and 90 degrees. So this part here, we always have a positive cos and a positive sine. So a positive cos with a positive, so this part, as we can see, this is on the positive side of the axis. So we're always going to have a positive value for x and a positive value for y. And the gradient is also positive because a positive divided by a positive is also positive. Then we're going to look at theta equals to 90. So theta equals to 90 is this angle here. So this is when theta equals to 90. At this point, if we look at the x values, this is equals to 0. Then the y value is going to be 1, because at this point, my height is 1. So my y value of sin theta is equals to 1, and tan theta is undefined because we can't have undefined. And because the vertical line did not have a well-defined gradient. Then we're going to look at this angle here between 90 and 180. So this part here, which is between 90 and 180. So the values for my x, so this is negative. So all the values here is negative, x is negative. Then y, the values for y is positive. So each of those, for example, this could be minus 0.1 and for x, and then positive 0.5 for y. So all the values are here is, just pick any point. So on this angle here, so any values between here. So my x values on here could be minus 0.5. So each value is always going to be negative. And my y value is always going to be positive. For example, here it could be positive 0.9. And when a positive divided by negative, we have a negative gradient. And tan theta is always going to be negative. Then we look at 180. So this is our horizontal line here. So at this point, my cos theta, which is our x value, is minus 1. My sin theta is 0, and my tan theta again 0 divided by minus 1 is 0. Then we're going to look at the angles between this range here, which we have is between 180 and 270. So if we pick any point here, we just have a look. So the values for my x is going to be negative. So let's pick this point here. So the values for my x is negative, and the values for my y is also negative. And negative is a negative divided by a negative, so we have a positive gradient. As we can see, an upward slope is a positive gradient, and theta equals 270. And so cos, so this is this line here. So my x value is 0. My y value is -1. So remember, it's our unit circle. Maximum is +1 and the minimum is -1. Again, it's vertical. The tan theta is undefined. Then finally, looking at our thetas between 270 and 360, which is this part here. So let's do a line here. So let's pick this point here. So looking at it, so my x value is positive. So my cos theta is going to be positive for thetas between this range. Then my y value is always going to be negative, because this is a negative y value. And my gradient is a downward slope, is negative. Also, my negative sin theta divided by a positive cos theta will give you a negative tan theta. Then next, so just have a look at here. So to find out the individual values a bit faster, for example, we know sin x is the same as sin 180 minus x. So a sketch of the sin graph you can see here. So we have sin 30 is the same as sin 150. Again, a sketch of the cos graph. So cos x, so for example, cos 30 is the same as cos 330, because it repeats every 360 degrees. As we can see, because the reflection property, so we know this part angle here is going to be equal. And sin theta and cos theta repeats every 360 degrees, but tan repeats every 180. Therefore, if we want to know sin 390, we know this is going to be the same value for sin 30. And another one, so sin x is also the same as cos 90 minus